All right, friends. So again, this is page 471, lesson 21, session 1. Okay. So up where my purple pen is pointing, it says, how can number lines help you understand fractions? Understand fractions. Let's take a look at the model. It says this number line shows whole numbers. The distance from each number to the next is 1 whole. Complete the number line by filling in the missing number labels. And this is what they're talking about right here, friends. They're talking about these labels here. They're asking you, what's supposed to go there? What is supposed to go there? And so what you can see here are bars. You're seeing these kind of like rose pink colored bars right here. And these bars are telling you, well, here's a whole. So for your brain, it might help like that's a whole pizza, right? So like here's a whole, that's a 1. And then here's a whole, that's a 1. And then here's a whole, and that's a 1. What this question is asking you is, how many holes do you have? Label that. Okay, so right below these bars is the number line, right? Here's the number line. Of course, our big learning target right now is the number line. It's asking you to fill in from 0 to here. How much is that? Well, that's 1. And from 0 to here, how much is that? 1, 2. And then it's saying from 0 to here, how much is that? Well, 1, 2, 3. That's all that this is asking you to do. It is asking you to see that this is a number line representing whole numbers. And again, up until now, up until 3rd grade, this is how you've seen number lines representing whole numbers. Number lines can go on a long way, friends. We're stopping at 3 here out of the interest of space and time. But if you take a look at question number 2, it is also saying that fractions are numbers that name parts of a whole. And we did learn that in lesson 20. Again, fractions are numbers that name parts of a whole. You can show fractions on a number line too. On the number line here, the whole that is between 0 and 1 is divided into equal parts. Label each part of the area model with the unit fraction it represents. There's a lot going on here, friends. So first of all, important to remember that this number line here represents 1 whole, only 1. The fundamental difference between what we just did above and what we're looking at now are how many wholes are being represented. So friends, again, we have a whole and then a second whole and a third whole. Down here, it is just 1. Notice how we go 0 to 1. That's it. So if it helps your brain, I want you to think about this number line as this is your pizza now. This is your pizza. This is 1 whole pizza. And that pizza is cut. That pizza is cut into 1, 2, 3, 4 pieces. It is asking you to label each part of the area model with the unit fraction it represents, friends. The unit fraction. Unit fraction. In order to do that, what needs to happen? You need to know what a unit fraction is. Again, a unit fraction, 1 in the numerator. 1 in the numerator. All right? They're special. So if we are going to label this area model with unit fractions, I want you to follow me on this. This section is what we call 1/4. Why? Because this area model is broken up into fourths. So the rules of fractions state that the denominator is going to represent the number of equal parts in the whole. So we know that it's 4. So we do know that this denominator in every single unit fraction, of course, is 4. We know that this section is 1/4, and this section is 1/4, and this section is 1/4 too. So we have a 4th, and a 4th, and a 4th, and a 4th, which equals 1/4. Now, friends, what you could do, if you wanted to challenge yourself a little bit to see this a little more conceptually, is again to take a look at the numerators in this unit fraction on each section. And what you could do is add them together. And that would represent the whole. So you could say this one plus this one plus this one plus this one, that is going to equal 4/4. That's the whole pizza. How do we know when a fraction equals 1/2? It is when the numerator and the denominator are the same. When they are exactly the same, you have described 1/2. I've taken this unit fraction or this piece, and this piece, and this piece, and this piece, and I've added them together. This is the whole. This equals 1. Again, anytime the numerator and the denominator are the same, you are representing 1/2. 1/2. Let's take a look at this in another way. I'm going to bring back my fraction tiles, and I want you to take a look at the yellow. Seems appropriate for spring, yes? The yellow. I want you to take a look at this now. And we're going to pretend that this long red line down here, this bar, this 1, is our number line. Focus on the yellow. Here's a 4th. Here's a 4th. Here's a 4th. Here's a 4th. Notice how all of these together equal 1/2. 1 pizza. All right. This is what is here. These fourths equal the whole. Okay. Now, let us proceed to page 472. 472. Please take a look at the top, that green modeling. Number 3, we're going to keep going forward. It says, you can count fractions on a number line just like you can count whole numbers. And you can see, for example, 1, 2, 3, and 4. So it is now asking you to fill in the blanks and by counting these fourths. Can we do it? We absolutely can. The first one is done for us. Here's 1/4, which is here. Here's 2/4 and 3/4, and of course 4/4. fourths. 4/4. Can we also label the number line? We sure can, because here's a fourth, and here's 2/4, and 3/4, and 4/4. And take a look at this, my friends, on the number line. It is very similar to the fraction tiles I just showed you. Take a look at here. Here's the number 1, here is 4/4. Anytime your numerator and denominator are the same, you are representing one whole. All right? We're going to go a little bit further now on question 4. On question 4, please take a look at it. You can also use number lines to show fractions greater than 1. I'm going to say that again. You can also use number lines to show fractions greater than 1. It's going to ask you to complete the number line below by filling in the missing fraction labels. Can we do it? Oh yes, we absolutely can. Friends, I want you to follow along with me, and I want you to take really good notes here. Okay, here we go. First of all, let's take a close look at this number line. Of course, it starts at 0, or the absence of value. It starts at 0, nothing. You can see here at the top, we have a whole represented. Here's one whole. And then we have another whole represented. Here's 2. So for now, I want you to just take a look at right here. This is your number line, right? We have 0, 1, and 2. And again, up until now, up until 3rd grade, this is how you have seen number lines with whole numbers. 0, 1, and 2. But what if we take those whole numbers and we cut them up? We cut them up. This is what we're about in 3rd grade, friends. We're going to take this whole number situation and we're going to cut it up. All right, so here we go. So our pen is going to be like the knife right now when we do the cutting. Take a look here at the fractional components below the whole numbers. I want you to take a close look at this. Here's a fourth, here's a fourth, here's a fourth, here's a fourth. The same exact thing we did here. But this number line goes further, because now we're not just representing 1, now we're representing 2. But the fourths keep going, friends. Here's a fourth, here's a fourth, here's a fourth, here's a fourth. Let's label it. You're going to have 1/4. Great. And then you're going to have 2/4. And then you're going to have 3/4. And then you're going to have, 4/4. And look at that, there's one whole. There's one whole, because the numerator and the denominator are the same. We're not done. We have a whole that we haven't even addressed yet. I'm going to change my colors to distinguish between the two, but we're going to keep going. Here is 5/4. Here is 6/4. Here is 7/4. And 8/4. Now we have another whole. Here's a whole, and here's a whole sliced up into fourths. Bigger idea, friends, that every 4/4 you count is one whole. Could this keep going? Of course. Could we have 9/4 and 10/4 and 11/4 and 12/4 to make 3 wholes? You bet. How about 13/4 and 14/4 and 15/4 and 16/4 to make 4 wholes? Absolutely. Could this go on forever? Absolutely. The bigger idea here is that you can represent whole numbers on a number line. You can represent fractions on a number line. You can represent multiple whole numbers on a number line, sliced up into fractional components. Number lines have many uses, friends. Many uses here. All right, reading down below, it says, some fractions greater than 1 have a whole number part and a fractional part. This is called, wait for it, this is called a mixed number. A mixed number. Look at the fraction you labeled 5/4 on the number line. Since 4/4 is a whole, 5/4 is the same as 1 whole and 1/4 more. 1 whole and 1/4 more. You can write this as the mixed number 1 and 1/4, or 1 and 1/4 more. 1 is the whole number part and 1/4 is the fractional part of the number. Again, friends, anytime your numerator and denominator are the same, that's 1 whole. Anything outside of that is the fractional piece. All right? So I want to take a quick look at this reflective question before we come back together as a group for just a moment. All right, it says to look at the fractions on the number line in problem 4. Here. Why do you think the numerator and denominator are the same in the fraction that names 1 whole? Here. Why is it the same? So friends, and please take these notes here. If you have four parts of a shape, and there are only 4 parts in the shape, then you have the whole shape. If you have 4 parts of a shape and there are only 4 parts in the shape, you have the whole shape. So again, going back to your pizza friends, if you take a pizza and you cut it into 4 pieces, you eat all 4 pieces. You've eaten the whole pizza. Okay. I'm going to leave this up for just a moment so that you can finish up with notes, and then we are going to come back and talk for just a moment.
Miss D,